Right. Hi, everybody, and welcome to this last session of today's open day. We're waiting for quite a few more people to join. They're rapidly coming in. You may or may not have seen me before. I'm Ursula Spivak. I'm the Faculty Admissions Officer. And this talk is aimed at parents and supporters. And here to give you this last talk of today is Professor Colm-cille Caulfield. He is an applied mathematician and is the head of our Department of Applied Maths and Theoretical Physics. I'll wait a little longer just for a few more people to join, but I'll now leave the floor to him. Thanks, Colm.
Thank you. Hello, everybody, and welcome virtually to the Centre for Mathematical Sciences here at the University of Cambridge. My name's, as Ursula said, my name's Colm-cille Caulfield. I'm the head of one of the two constituent departments of the Faculty of Mathematics. There is the Department of Applied Mathematics and Theoretical Physics, which is the department I'm in, and the Department of Pure Mathematics and Mathematical Statistics, so our sister department, and together we form the Faculty of Mathematics, where we conduct education and research in mathematics here at the University of Cambridge, and in particular at this beautiful Centre for Mathematical Sciences, which I would love to be able to be welcoming you all to today. This is actually the roof over the central core, where many of the supervisions go on, with the lecture halls in the lower ground floor, what many people would call a basement, I guess. And as also said, I'm the head of the department and an applied mathematician, but also I'm a fellow of Churchill College, one of the 31 constituent colleges of the university. And there for, I think, 5 years, I was one of the admissions tutors, and I was involved, and I've also been a director of studies there, and I still supervise for the college. So I'm very much involved in the recruitment and the teaching of students. But today, really what I want to be talking to you about is more from the side of the supporters, the sort of people who might be wanting to support applicants to this wonderful university, and to have the opportunity to come and study and eat your lunch on the roof of the Centre for Mathematical Sciences, which does indeed really is quite reminiscent, I would say, of Teletubbyland from people's childhood, with that lovely curved roof. So what I want to do in the next 45 minutes or so is tell you about, really try and address these two questions. The sort of what are the expectations we have on students, and what do we want from a successful applicant? And it's very important to appreciate that Cambridge is different. Indeed, every university is different. And so you really want to know whether the way we teach mathematics and the way the situation is set up here is whether it is the right environment for the applicant that you will be supporting. Will they fit in? Will they enjoy the course? Will they do well? And you know, of course, there's money involved too. Is stuff affordable, of course? And I hopefully will set your mind at rest about that particular detail. But whether the right for the system we have here is really, it's essential that they are very motivated and very enthusiastic about mathematics and have mathematical ability, of course. And if they love mathematics and love working hard and want to excel at mathematics, this is an excellent environment for that sort of situation, because there are many ways in which this university and this mathematics program is really quite different and quite unusual. And so if you want to think about some of the aspects of what distinguishes us, well, we're one of the broadest and largest faculties of mathematical sciences in the world. We call this the Centre for Mathematical Sciences, and I often use the phrase to say that we're really quite a broad church. Mathematics is very broadly defined here. You know, it's kind of the hints in the name, right? You know, we are the Department of Applied Maths and Theoretical Physics. We have a fantastic set of courses and a set of colleagues who are interested in understanding the universe and studying theoretical and researching theoretical physics, great heritage in physics, and also, of course, a great heritage in pure mathematics and in statistics. You know, so a very, very broad range of different subjects. Indeed, the director of the statistics laboratory, the sub-department of the statisticians within DIPMS is what we call it, the Department of Pure Maths and Mathematical Statistics. Richard Samworth was just elected a Fellow of the Royal Society this week. So, you know, we have this great breadth. And in our department, we had Ben Simons, was also elected a Fellow of the Royal Society, and he's very interested in biological systems. He also works at the Gurdon Institute. So very, very broad, you know, people interested in the mathematics of healthcare, interested in modeling epidemics, interested in fluid mechanics. That's how the oceans move around. That's my interest. It's all very, very broad range of research activity and very broad range of teaching possibilities as well. I'll come to mention. We have, each of the departments has about 60 full-time members of staff, and then of course there are many people who are predominantly employed by the colleges in various teaching and research roles that also play a very important part within the faculty. So we have a very, very large number of academics, staff and students and postdoctoral researchers here. And so that gives us a chance to do a very, very broad range of courses. Our final year of the undergraduate program has 35 different courses in it, very, very wide range of choices that students can study from whatever takes their interest, you know, from statistics, very pure mathematics, number theory, topology, and so on, through analysis, you know, like the proper rigorous underpinning of calculus, through many different applied mathematical situations, mathematical biology, waves, cosmology, you know, theoretical physics, you know, quantum mechanics, various aspects of quantum mechanics, very broad range of things that students can take. And so we really think that this is one of the very best places in the whole world to learn and to research and to teach mathematics. And one of the key reasons for that is actually the quality of our students. Our students are just amazingly good, enthusiastic, and like everybody else at the Centre for Mathematical Sciences, we all love mathematics broadly defined. And so we're all very, very, very interested to learn and to teach and to communicate about mathematics. So it's a fantastic environment in which to study if you have the opportunity. I certainly would recommend it. So what distinguishes Cambridge, of course, Cambridge is a very famous university, dates back over 800 years. It has this collegiate structure that every student is associated with a college, which has a really beautiful aspect that you can be part of something that's very large. You know, our year cohort of mathematicians is about 250. So, you know, and having a large cohort like that means that there's 120 academic staff, like I said, so there's a wide range of courses, so you can do whatever you like. But because of the college system, I know that you will always feel then this smaller community. Most colleges have a year group in mathematics of 10, somewhere between, you know, around 10, 15 or so. Trinity is bigger, it's typically over 40, but most of the colleges are 10 or 15 or so. And so then you have an opportunity to really get to know the other people in your subject. And the college system also means that there's people to support you. You never have to worry about dealing with dodgy landlords because the colleges accommodate you throughout the period of the course. And also because of the accumulated endowments in the colleges, you get an awful lot of support through the sporting facilities are excellent, the music facilities are excellent, and also the teaching, the small group teaching we do, the supervisions, which I guess called supervisions because they're called tutorials in Oxford. They're one person like me, like I say, I supervise for my college and for other colleges on the more advanced specialized courses. But so one person holds the supervision and two students typically attend it, and you go through example sheets, example questions associated with the last 2 weeks of the lectures. And they are incredibly valuable pedagogically for students to really embed the learning of the content that's been given in the lectures in this small group teaching, and you get a fantastic amount of attention. But once again, and the distinguishing factor, I would say, of the colleges of the Cambridge, it has this history, this collegiate structure, this endowments which allow us to do this form of teaching. And why that is excellent is because of the quality of our students. The students can then absorb and can benefit from all this marvelous form of teaching that we give, and this wonderful opportunity to learn mathematics in such a rich environment. Intellectually rich, just not, I don't kind of mean full of gold. Now, what is it? So it sounds like a nice place to come. How do we do our admissions? Well, our policy is to admit students, of course, of the highest intellectual potential. Very important, that concept. It's the intellectual potential, irrespective of other considerations. And we have aims, we aspire to encourage applications from groups that are at present underrepresented. I'm an enormous believer in equality, diversity, and inclusion. The diverse groups are just a much better situation. We've still got work to do to have a very diverse year group, but we certainly do our utmost to address that. And also for the admissions process to be fair, it should go without saying, but most definitely is our case, and is something that is right at the heart of the way we proceed. We ensure that every single applicant is individually assessed. When I was an admissions tutor, I would read every single file of every student who was submitted. Then the people who were doing the interviews would read all the files of all the people that were being interviewed. We would have after the interview process, we'd have what's called a decision meeting, and every single candidate would then be discussed. It's incredibly labor intensive, but it's very, very fair, and it is based around a concept, a key concept, because there's calibration processes and moderation processes associated with what we call the pools, and I'll come on to talk about that, but you may well have heard about that already, that the chance of admission to Cambridge is not a function of the particular choice of college that you have made to apply to. Now, of course, not every student ends up in the college to which they directly applied, because there can be a mismatch between the number of applicants and the number of places available in an individual college in any one year. But we have these moderation processes that sort out to ensure that the best students, the most deserving students within our measure, the ones with the highest intellectual potential, do indeed get in somewhere. And indeed, that is not a barrier to achievement by any stretch of the imagination. We have this concept of the senior wrangler, the person who came absolutely top. And when I was at Churchill, we had one of these students, and they had been pulled to our college. The student that came absolutely the top in the final year exams had come to the college through a pool. These are not problems. It's no problem. And very often people, when they end up being pulled to a college, say, wow, what a lucky escape. I've ended up at the right college, or not at college B, the one I was pulled to, rather than the college A I applied to. You just end up typically falling in love with your own college. So that's great. So numbers, really, there's about 5 applicants or so for every place in Cambridge mathematics in terms of the year group. It's somewhere over 1,200 applicants in a typical year, and we typically only admit about 1/6 of the students, 20%, even though all these students are ones that are getting 2 A stars or better in A level. So it's very important to think about what is it we're actually looking for in our applicants. Well, we've got to say there's got to be genuine subject interest and enjoyment of mathematics. You've got to really love doing maths, broadly defined, because it's, we want you to do lots and lots of it. It's going to be a very intense environment. You're going to have opportunities to do very large amounts of mathematics. You've got to have some core knowledge and technical fluency. We do you have to be able to do your algebra quickly and accurately. You've got to be comfortable with sort of seeing the patterns and the symmetries that underlie so many different things in mathematics. You've got to be good at understand a logical argument so that you can construct a proof correctly. It's one of the beauty of mathematics is its precision and its absolute certainty. And you've got to be the sort of person who finds that great. That's the thing. And we're also very interested with potential. The development that is going to happen in the 3 or 4 years you're here as an undergraduate student is enormous, from what you're like when you just finish your school leaving examinations to when you finish, hopefully, our master's level courses at the end of the 4th year. Incredible amount of development. So you've got to have the potential to be able to deal with that. And how we sort of assess that potential is you've got to be intellectually flexible. You've got to be able to absorb new information, and you've got to be not wedded to a particular way of doing things, because there might be a better way, or there might be a way to generalize it. And so you've got to be intellectually flexible. You've got to be excited. You've got to actually like complex and challenging ideas, because then you're going to get better and better and better at doing things. And that's the kind of aspect we want you to do. You've got to be prepared to work hard. And this is often an issue that can be the sort of students who we want in terms of their talent and ability are often finding school mathematics easy. But we want to have somebody who is then prepared, but we've got to try and identify people who are prepared, who really enjoy working hard and dealing with the difficulties and going on, rather than just wanting an easy life. That's a key aspect. So you've got to be somebody who's good at learning independently and thinking critically and analytically. So, you can look at this particular link I've got here, but the way I remember this mnemonically in the sort of way of the things we're looking for in our candidates are as follows. Tips. We want somebody with talent. You've got to be good at maths. You've got to be interested in the maths. You've got to really love it, because this is a place that you've got an incredible amount of opportunity to do things. So you've got to really be interested in it. The worst case, absolutely the student we don't want is, well, I'm going to do maths because I don't like writing essays, so all the art subjects are out, and I don't like doing experiments, so the science, or I'm making things, so science and engineering's out. Oh, I was quite good at maths at school, I'd like to do that. That is not the sort of student we want. We want a sort of student who just loves doing maths and will just love doing more maths and maths and maths and maths, because that's the sort of environment that we're in. It's a crowd of people who just love maths. It's got to really be interested in it. So TIP, performance. You have to be doing well at it. You have to be able to demonstrate that you can do well in examinations, because thriving here, we do have demanding examinations. So the sort of student who does well here is somebody who is also good at enjoys the challenge of doing challenging examinations and can demonstrate performance. And then the last one, S, just to make a mnemonic, sweat. You've got to be somebody who actually enjoys working hard, because there is the opportunity to work hard. Somebody who can, like the analogy I often draw is with respect to running a marathon, right? The sort of person who runs a marathon and enjoys the achievement of having finished that marathon and done gone through the wall and raised that money for charity or whatever, knows that has to be the sort of person who's prepared for months to train to be able to run that marathon. And that's the sort of situation you have here. It's wonderful to learn all this stuff, and it's beautiful to get the insights into the way the world is described so well by mathematics and the beautiful structures of mathematics themselves. But it takes work to get there, right? It doesn't just automatically happen. The stuff we're doing here is challenging. And so it really is the place that you've got to be the sort of person who's prepared to work. And of course, these aspects are the component of self-interest, because it's great fun for us to teach hardworking, enthusiastic students. It's an amazing experience to do these supervision. Sometimes it's a bit, you've got to be on your toes, right? Because the really, really penetrating questions that you're asked, really so impressive. The questions I'm asked in supervision, showing how deeply the students are thinking about the subject can be a bit humbling, really. Sometimes when I supervise the course that I am lecturing myself, because they found, well, in the lecture you said this and it wasn't, yeah, you're right, that wasn't entirely clear, I should have put it this way. And you know, that is really wonderful, because, you know, I like maths too, and all my colleagues like doing maths too. So it's a great situation to have these sorts of dedicated, hardworking, and intellectually curious students to teach. So, what are the more details? Of course, what's the information used in our selection process? So we look at your academic record. Not just, you know, many students come with A levels, but we're very experienced dealing with Scottish hires, the Irish Leaving Cert, the International Baccalaureate, European Baccalaureate, etc., etc., etc. These different qualifications. And then we also, of course, use in our selection the STEP, the sixth term entrance paper, the exam that is taken, that can be taken typically directly after the A levels. Now, step two contains the content of further maths AS level, but it's still really kind of core. And step three has all of the further maths in it, but it's much closer approximation. The structures of the questions, you know, they're longer, they require more synthetic and flexible approaches. They're much more closely allied to the type of things that assessments that would happen at university. And it's not just here, you know, there are, if you went to Warwick or you went to Imperial or you went to Bristol, your first year examination questions would look an awful lot more like STEP questions than they would look like like A-level questions, right? There's much less step-by-step aspect to them, like A-levels are very, you know, organized in the way you go towards the answer, much more synthetic in STEP. We look at your reference, of course, in the application materials. It's very important to understand, for your teachers to think you're a hardworking, enthusiastic student. And we are very focused in particular on contextual data, you know, from the environment you have grown up in, or the candidate has grown up in, how they've dealt in that situation. And so we are very skilled at inferring, you know, if typically the school is a school that doesn't send many students to Oxbridge, we factor that into the process in terms of the performance of the students and also the supporting documentation. Whereas, you know, other schools with the long-standing experience of the system and many students who come to Cambridge, then we also understand what those references mean and what that performance means. And then also, of course, how you get on in the interview. But we're very data-driven, but still, you know, how you interview, and we'll talk about that I'll talk about interviews a bit more in a moment. But the personal statement is not particularly significant for us. Of course, we read it, but it's not, there isn't sort of a point scoring system about, you know, you did oboe grade 8 or you did Duke of Edinburgh bronze or whatever. You know, that isn't quite such a, we want to see that you're enthusiastic about mathematics, but the sort of extracurriculars do not feed into our process decision making as much as I believe it does in other universities. That doesn't mean that you shouldn't mention, that extracurriculars shouldn't be mentioned, but they're not actually a big part of what we look at. But we do most definitely rely on use STEP. I'm going to come furthermore to the sort of numbers. And one of the reasons that, well, there's multiple reasons for why we use STEP. I really believe it's excellent preparation for university mathematics. If you do the preparation, if you prepare for STEP, you are inevitably, your mind is being set more along the lines of the sort of ways that you're going to have to study and answer questions in university mathematics, wherever you end up. So I think that's really a good point. And it is taken at, we believe it's fair that you take it at the end, because it's that's when you've really absorbed all the information compared to, let's say, the use of matter earlier in the process. And it's very well, performance on STEP is very well correlated with performance at subsequent universities. But also, and I really think this is a very good process, we really interview a very large proportion of the number of students who apply. it's about 75% are interviewed. So really, if your teachers say we do sometimes see applications where the teachers are saying, are really not even predicting an A star in further maths, for example, which would be unlikely to be a student who is going to do. There are, of course, situations, but if there are where that could be explained, and so we do indeed interview such people if there's contextual data. But there are typically some candidates who really we don't think Cambridge is right for them. But that's only about a quarter of the applicants. So we interview a lot of the applicants, and we're given offers to about over a third of the applicants, because only about half of them, less than half of them make their offer, i.e. our typical offer is 1-1, and only about 160 or so people make 1-1, and we then look at the margins, we look at the step papers, we look exactly where they sort of went wrong, and then make decisions about whether we take them or not. But we really believe that this is the fairest way to do admissions, because we look at a lot of the students, and we many more than Oxford, for example. Oxford uses their admissions test much earlier in your studying period, in the November of year 12 to year 13, sorry. No, it is November of year 13, sorry. And they, but it's much, whereas we do the step at the June, right at the very end. And much smaller number of people interviewed, but then the offers at the interview, typically the people who are given the offers, many more of them actually get in, because the offers are typically just on the A-level grade. So that puts a lot more weight, I would argue, on interviews, whereas we put much more argument on actual mathematical performance, which I think is something that I believe is fairer. Now, what do our interviews like? Well, there's usually two interviews conducted by two mathematicians, or often if you apply for the maths and physics stream, there'll be one of the interviews will be with a mathematician and a physicist. Though once again, it could be somebody might self-identify as a theoretical physicist and still be teaching in our mathematical tripos, and so certainly we do that. And then, but these interviews are just like hello, and then maths. Start sketching something, talking about one of these. Often these kind of SOC problems with probability. No hidden agenda, no trick questions. There's no need for applicants to ask questions, but they're typically always given an opportunity at the end. But really, this is an exercise in seeing if you're the sort of student who A, loves maths, B, has a facility at maths, and C, has this intellectual flexibility, being able to take hints on, so supervisions, we have this small group teaching where somebody gets stuck, and then you have to explain to them where they've got stuck and kind of give them the steps to make the connections. And so the interviews are often that sort of situation. They're deliberately, the sort of questions we design are deliberately structured to get harder and harder and harder until the student gets stuck. And then how do they talk about why they're stuck, what an idea they have that doesn't work, and then to be able to take on a hint and understand what's going on. So it's really testing if you have the sort of way of the mind might work to thrive within the Cambridge teaching and learning environment. And it's just, a perfect interview is somebody can say, oh, wow, it was really interesting, but it was really hard. They kept asking me harder and harder questions. And it felt like it was, my head was, I was out of my depth and I was bobbing down, but I would always manage to just paddle. And then I understood the hint I got and I was able, and wow, I just got through. It was really interesting, but really difficult. That is a really good interview. That's an interview that's gone really well. And that's exactly the sort of student we want to have. I honestly, when I have interviewed, I've had some people who didn't want to leave the interview, who wanted to keep talking because they found it so interesting. I've had people email me with kind of ideas where they had got stuck and they'd worked something out, and then they email me afterwards and say, I know this is too late, but I thought the question was really interesting. Is this the answer? Those sort of enthusiastic people who are intellectually flexible and can think how things go, they're the sort of students that we want to attract. As a top tip, Do not talk about questions with other applicants. It doesn't really help matters. And if somebody says, "Oh, it was straightforward. I answered all the questions. They were really, it went really well." That's not gone really well at all, because if you could answer all the questions, it means that you were deliberately being asked simple questions, because as soon as something difficult came along, you weren't able to, the hinting didn't seem to work. So don't stress it, enjoy it, work on your maths, and just be excited to have the opportunity to talk about some interesting maths for 2.5 hours. Our typical offers for about a third of the people who we choose to give offers to: 1-1 in step 2 and step 3, and 2 A stars in A level. But some colleges, you should contact them out, are doing a flexible offer to deal with people who might think that we have a belief that this will attract more people from traditionally underrepresented groups, is kind of give a safety net, a flexible offer, which is that either you have 2 A stars and get the 1-1 in step 2 and step 3, or you get 3 A stars from within your education, within your school environment, and you get one of the 2 step papers, you get a grade 1. Now, for dim and distant, not entirely known regions, step papers are graded. S is the top grade, sort of what would normally be called an A, I guess. 1 is the second grade, the equivalent of B. 2, 3, and then U, rather than using letters. I don't really understand the reason, but so a grade 1 is the second grade. It's not it's good answers, most definitely on step, but it's not the very top grade. And indeed, there is evidence that this is increasing our diversity of our pool, which is exactly what we want to do, of our applicant pool. Now, how does the process work? You apply directly to a college, and so, as I said, there is a moderation system which we call the pools, which allow us to ensure that the college that you applied to does not affect your chance of getting into Cambridge. So you might say, I can't possibly come to a decision on the college I want to apply to. I'm just going to send an open one. If you send an open application, then you are allocated to a college that has relatively small number of applicants in that subject area. And that allocation is therefore done as if you had applied to that college directly. So some colleges get a lot of applications associated with some subject, some colleges get a relatively small. So for example, Churchill, my college, is the only college that has an overt policy. It's in the constitution, the statutes and ordinances of the college, that 70% of the students are in STEM subjects. So we have loads of mathematicians directly applying, whereas in some of the art subjects, we have relatively small number of applicants. So if you're an open applicant, you get allocated to Churchill in one of those art subjects, as if you'd applied directly to Churchill. So if you really can't decide, this is the process that you will happen. But I think it's a good idea to decide which college you want to go to for whatever reason, that it's got the playing fields nearby, that it looks like Hogwarts, that it doesn't look like Hogwarts, that somebody famous once went to it back in the day. These are all perfectly valid reasons to choose the college, because it doesn't really old, new, big, small, they're matters of personal taste. So you apply to a college, 75% of you of applicants get interviewed. Then we have this decision meeting just before Christmas. What's the decision meeting? Well, you could get an offer, you could be definitely rejected, or then there's certainly occasions happen where colleges get more good applicants than they have places, and they say, well, look, a previous year, this particular applicant would have certainly looks good enough and would thrive here, but because we've got lucky this year and we've got a lot that look even better on paper. Well, maybe the college down the road didn't get the same number of applicants, so we'll put that applicant's paperwork in what's called the pool, and then that other college can fish in the pool and look to see. So then in the first week of January, we get together all these files, well, electronically happens now, but we get together all these files, and you look through them and you try and identify people you want to fish out of the pool. In mathematics, it acts kind of like the American football draft. All the different colleges, directors of studies get together and they go round in a determined order of fairness, and then they select the people that they want to take out of the pool. And a large number of offers come out of the pool. You know, we typically do like 150 offers in mathematics come from pool candidates. It's very common phenomenon, and indeed, you know, a large maybe a quarter of students end up in a college that wasn't the one they applied to directly. So there's the winter pool. Then we get this. So then you get told you might get an offer from a college you didn't apply to. You know, you applied to Trinity, but you get an offer from Churchill. You know, this happens. Then you sit your step exam and you get your results. And if you get your 1-1, you're in. But about 30% of the students, it's only typically about 160 students get 1-1 or better. About 30% of the students we admit didn't actually get their step offer. So there's then a summer pool when some colleges reprieve them, just say, okay, well, we're still going to take that student. And others then say, well, no, we can't take them because we got really lucky this year and we had so many 1-1s that we're filled up. One year it happened to me, you know, Churchill aimed for 14 and we got 19. The people that we chose did much better at the exams than we were expected. So we had a very big year group. And so we had a couple of people who just missed, you know, who got 1-2, but they're a few marks short from getting a 1-1. They then are put into what's called a summer pool, where a college might have, okay, well, nobody came close or some of our direct applicants didn't come anywhere near close, and we'd actually rather think it's fairer to take somebody who just missed it from another college that by statistical anomaly got overfilled. So there's the summer pool, and there you can ending up at a third college from, you know, so you could apply to one college, be pooled in the winter to a second college, get an offer from that second college, and that second college then say, then you miss your offer for that second college, but a third college takes you out of the summer pool. This happens. Doesn't matter, you're in Cambridge, it's all great, but it's just it's a process to make sure that we're really trying to make sure that the very best, the most deserving students, the ones with the highest potential, get in, irrespective of the college they happen to choose to apply to at the beginning. So I hope I slightly explained some of the mechanism. So what do we offer? I'd say we offer great teaching with fantastic student support. There's guaranteed accommodation for all the years that you're an undergraduate at the college, rented for 30 weeks. It's great. Excellent career prospects. We'll get onto that a bit. And loads of different clubs and societies for whatever your interest is, whether it's tabletop games, whether it's ultimate frisbee, whether it's soccer, rugby, hockey, rugby league, Gaelic football, music of all varieties, jazz, popular, whatever that might mean, through classical. Of course, there's amazing theatrical opportunities too. And, you know, so for example, one of the great attractions of the college system is you can play sport at kind of any level, right? You know, from the sort of varsity representing the university, but also you can be on the second soccer team, second 15 of the rugby for your college. And, you know, if the colleges with a few hundred students, you know, that's just a rock up and play with your mates. And it's great. You know, there's all this different levels of opportunity. And to say we've got good teaching, you know, we've got the appropriate gold medal from the government, but it's really, I would argue that the way our situation is set up is really, really fantastic, because you have really top quality lectures, and you also have these supervision. So the first year is a compulsory structure. It kind of gives you a kind of pattern of what it is. You do 8 courses, 4 before Christmas, 4 after Christmas. Each of those courses has 3 lectures associated with them, either Monday, Wednesday, Friday, or Tuesday, Thursday, Saturday. Yeah, we lecture on Saturdays. And so you have these lectures, each of which are then supported, as they say, every 2 weeks, there's an example sheet given out, and you have a supervision one lecturer or postdoctoral researcher or PhD student who really knows the subject. Two, small groups. One, you hand in your work 48 hours before, it's marked. You then discuss where you went wrong. You then can go through questions you couldn't do. And what's fantastic, particularly for the supporters of these students to know, there's no escape. There's nowhere you can hide. If you're quiet, or if you're in a situation where you have example classes with 15, 20 students, it's going to be the chatty, pushy ones who are going to get the attention of the lecturer, and you could just quietly hide in the background. There's no way you can hide here. You are going to get supported in your teaching. Stuff is very fast, but you have an amazing amount of support. Now, when I say mainly of these lectures are chalk and talk, we believe that gives a good pace, because you turn around, you write. When we've been doing them remotely, two of our lecture halls are set up with cameras, three cameras pointed at each of the three chalkboards, so students could watch along in that way. But also the way I lectured was using my iPad, right? So I would have, I'd be doing a session just like this, and there would be the iPad, and I'd be writing on the iPad in real time as if I was lecturing. So could be a bit more colourful, and there was also a record for the students of what I'd written, right? So we had a web page, there'd be a video of the lecture, there'd also be a PDF of what I'd written, so they could see what I actually had written, so they didn't necessarily have to be writing along, and printed notes. And of course, every lecture had a theme tune. So there was various supporting materials also available to them, as well as, of course, the supporting libraries we have. Every college has a library. We have a beautiful library here. There's great electronic resources, great ways to study. And, when I say we have these world-leading researchers giving the lectures, well, here's the sort of example of our colleagues. Julia Gog, OBE, who is a key member of the SPI-M, feeding into SAGE for the pandemic modelling. She's a world authority on modelling pandemics, so she's been pretty busy over the last year and a half. Two of the people in pure maths here, Coucher Burker, who's was in the last round, won the Fields Medal, the Nobel Prize of Mathematics, and Jack Thorne, the youngest fellow of the Royal Society living at the moment. He was elected when he was, I think, 32, which makes me feel slightly inadequate, but he's really a fantastic lecturer as well in number theory, as well as his brilliant teaching. So there we are. That's what we have for our teaching. And there is fantastic amount of student support. Once again, very much because of the college system, you are still in these cohorts where there's a lot of attention. Every student has the director of studies who organizes these supervisions, who sees the reports that are written. I give 4 supervisions on a course. I then write a report about how the student's doing, what they need to work on. The student sees this report, the director of studies discusses this with them at the end of term. At the beginning of term, they talk to them which courses they want to do. Lots of attention. Every 2 weeks, you're being seen by the supervisors. Developing problems can be identified. And every student also has allocated to them a personal tutor, who in our jargon, a tutor doesn't actually teach them. It is pastoral support for non-academic issues. Health issues, financial issues, they're the first port of call, as well as more wide university aspects. Very, very low dropout rate is associated with this, and there's a fantastic amount of support, levels of support and attention. But by no means are we complacent about this. We know there's a real issue about, particularly at the moment, but in general, of course, the stresses and strains of modern life with mental health for students. We're not complacent about this at all. We devote an awful lot of effort towards supporting the mental health of students and the staff indeed. It's a broad activity throughout the university. There's a commitment from the very top towards the well-being of all members of the university community. It's a nice place to work where people are really looking at this sort of things. There's also a lot of attention to the financial side of things. The fee is pretty much the same as as all other universities in the UK for home fee status students. But there is enormous actual subsidy of the education here that comes from the collegiate system through the endowments, because it really, the amount of small group teaching that we provide is very, very labor intensive and is amazing opportunity to a typical student. You know, so I say they're getting 4 typical, you know, the first year they're doing 4 courses a term. Every 2 weeks you get a supervision on that course. So that means you're having 2 supervisions a week. And remember, that is an hour of a real expert's time doing a tutorial session with you, having marked your work beforehand and discussing with you all the issues that you might have with those courses. Very, very labor intensive. And there's really a substantial amount of cross subsidy. And indeed, many of the all the colleges provide various support through the sporting facilities, music, drama, and so on. And there's also the bursaries, both at the university level, but often there's a lot from the college level as well. And then the final detail, which is I've kind of alluded to already for the supporters that I'm supposedly addressing, is that it's a very good place and is surprisingly cheap because of the fact that the colleges are your landlord. And so the rent, typical rental contract is just for 30 weeks because our terms are relatively short. But, you know, compared to if you're in London or Manchester, where in the private sector, you're going to have to sign yearly leases, it's just incomparably less expensive, right? You're only here for 30 weeks. You know, you don't have to try and find somewhere new. The most complicated thing is you have to put in, often you have to go into a ballot to get on the, you know, the south facing one or the one near the shared shower or whatever, right? You know, that you can select your room within the college, and typically the colleges have a wide spectrum of rooms, you know, from more basic ones, cheaper ones, to some really quite fancy ones that, let's say, for example, are rented out to in normal times for conferences, and students can choose where they want to go. So it's really not a crazy expensive place. It's really, that is one of the most important details to understand. It is not an expensive place to be a student, and because a major point of cost is accommodation, and you have a very, you know, your college is your landlord, so they're very good landlords, and you only have to rent the room for 60% of the year. It's just good. So what do people do after Cambridge? Well, you know, it's not an obviously vocational course, but mathematicians are in demand in all parts of the sector. It's really clear. You know, mathematicians have played a huge part in the present pandemic emergency. They have a huge part to play in the financial sector, which is one of the UK's biggest industries, of course, and throughout the business world more generally, and you know, classical manufacturing. There's an awful lot of mathematicians every which way. It's incredibly flexible background, because mathematics underpins everything in our world, right? We are so, you know, data, the digital world we live in, it's mathematics underpins that. And mathematicians are used to dealing with complex problems and managing to distill them or synthesize them to simpler sort of things. And provided you believe in expertise, mathematics is one of the great things of expertise. Now, the other aspects for the supporters to know, however, very close to half our students go on to further studies in either, you know, masters, PhDs, and so on. And because we have the sort of students who just love doing maths over and over and over and over and again, and so can continue doing maths. You know, I can't really throw stones at that, since I've, you know, we sort of went to university and effectively never left, and loving it to be able to do the maths. And you know, in our program, we have actually a 4-year program going towards the M Math. Only the top 100 or so are allowed to proceed to that. You have to, because it's very challenging course. So some students do a 3-year course and graduate after 3 years with a BA. Some do a 4-year course, and that 4th year really and graduate with an M Math. And at the end of that 4th year, they're very well prepared to do, and it's really designed to prepare students to do PhDs in the broad mathematical sciences through theoretical physics, to very pure things in statistics and so on. So we don't really worry about our students not getting employment, and they really, because it's a research-led teaching environment, it is important to appreciate that many go on to being mathematical researchers themselves, which is great, because we all need maths in our life. So that's the end of the presentation part of what I wanted to talk about. And now, please feel free to add further questions to the Q&A. But I now see there are 5 questions in the Q&A, so I'm going to read them out and try and answer them. So, can you provide any assurance that Cambridge is not now actively discriminating against prospective students who attend independent schools? I can give you a categorical assurance that we do not discriminate against any student on any criteria. Through encouraging applications and from historically underrepresented groups, and through through focusing on contextual data, embedding, relative performance in your school cohort, understanding the level of challenge and opportunity available to individual students, is in no way discriminatory against those people who have many opportunities or have had the opportunity to attend an independent school. An entirely true story. When I was an admissions tutor, I found 2 letters in my college pigeonhole addressed to me. One from a parent and one from a teacher. And the teacher was in the maintained sector and was accusing me of demonstrating overt bias against students from underprivileged backgrounds. And the letter from the mother was saying I had demonstrated clear bias against students from the independent sector. The evidence for this was that their candidates had not been admitted. And I just wanted to change those letters over and put them in the other envelopes and send them back to the other people. Categorically, there is no active discrimination. We are focused on admitting the best students with the highest academic potential, and we are laser focused on fairness. That is entirely consistent with encouraging equality, diversity, and inclusion. Absolutely self-consistent. So that's as categorical as I can be. My daughter is really struggling to decide if she wants to study maths or computer science at university, hopefully Cambridge, as she loves and performs well in both subjects. Any tips on how to make a final decision on course, please? Well, that's a really, really interesting question. And the division between, there can't be a wrong answer either. The difference between somebody who's very into mathematics and does computer science and somebody who's very into computers and does mathematics is going to be so well set up for the future, whatever happens. And, well, I was in a really interesting meeting with a professor of computer science yesterday, talking about what he does, and he does more recognizably mathematics in his research than I do in my research. Basically, a lot of my research is devoted to running extremely large numerical simulations of fluid systems on enormous computers with literally trillions of grid points. Well, when I say I do it, my brilliant PhD students and postdocs do it. But they can really be 2 sides of the same coin. I think the issue at sort of when you're at school age, the issue to determine is, what really excites you? Does excite the computer science would be, is it really actually the joy of writing a computer code that actually does something, from hello world to sorting data, to finding a pattern, to, turning the lights on, whatever, right? That the use of computation to do something, there is that sort of inevitably applied side. I'm a very applied mathematician. Whereas mathematics is more about absolutely, I really like to know something is true, to prove something. And I'm really interested in the aesthetics of patterns, because so much of mathematics is pattern and symmetry. So that absolutely, the computer science, I don't really want to put words in my colleagues' mouth, but there's often it is achieve something. You are doing something. You write code, you write your compiler, whatever, and it achieves something. It does something. Whereas a mathematician is just more mathematics can be more about I know this statement to be true. I see these patterns, and there is this joy in just having that ability to calculate. It's not, though I'm very interested in the application, the education will be more about this is how mathematics works, and this is the language of mathematics, and mathematics is beautiful for its own sake. And so that's really, I think, to sit down and think. But I would, if I did go to look at computer science, I'd really want to drill down to see if the course had if there's somebody who's quite interested in maths, because there can then be a spectrum of computer science which can get very close to engineering. Now, literally, some of my best friends are engineers, but that is even more focused on the ultimate objective of using science to solve a technological problem. So if this person, your daughter, is somebody who really likes maths and really likes computer science, you want to make sure it's more a kind of theoretical computer science, or there's a component within the course that can certainly be describable as theoretical computer science, as is our program here, which is superb, world class in that sort of area. Our engineering is world class too, but it's the spectrum, right? Or in some places are really quite applied, focused on the hardware or the software, but very much for the industrial kind of output, like engineering. So that's it. But no decision is the wrong decision, and go with your heart. I mean, it's just like, you'll come to a thing and say, you'll go to an open day like this, or you'll have heard a taster lecture of that, and you say, oh wow, that's what I want to do. And that's the way to make the decision. Is it possible to get an offer which requires S in one of the step papers? Yes, it is. So sometimes, for example, in that I've mentioned this kind of decision meeting, right? So what happens is typically there will be the directors of studies who often will be involved who will have been involved in the interviews, almost always, but not all the interviewees will be the directors of study. And the directors of study will be there with an admissions tutor and maybe the senior tutor. And there can be a little bit of horse trading on the margins, in the sense that the admissions tutor has got a holistic view across all the different subjects and the number of students they want to admit and typical patterns. And the directors of study will be trying to identify the best students in their subject area to come in to teach, because it's best fun to teach the best students. And it can happen that the admissions tutor will be looking at the data and say, look, I don't think this person deserves an offer. And the director says, well, the interview was fantastic, and I know, and I was really impressed, and And it could be, well, look, I'm really wary about this candidate for this red flag. The teacher maybe hinted that they were lazy, or it could be thought that one word from the teacher implied they weren't the hardest working. Then it could be, okay, well then I'm not confident about this. We'll give them a harder offer, because if they get an S, we're really fantastic. That's an example. That does happen. That isn't unfair. I would argue that's really fair, but sometimes if there's flags or there's issues and points of concern, there can sometimes be, okay, well, we will give them a harder offer because we really think they need. Or they could be Sometimes people who reapply get S offers because they've had longer time to think about it. They've studied for 3 years for STEP rather than for 2, or these sort of things happen. The standard offer is 1-1. Some offers are lower, but the standard offer is 1-1, and sometimes the offers are higher. Sometimes people who are taken out of the pool, sometimes in overseas, it's somebody who's been not interviewed by the college, then they're sort of wary and give a higher offer. It's unusual, but it's not unheard of. You've talked quite a lot about diversity. What about gender diversity? I understand girls are underrepresented at maths at Cambridge. Is this true across the colleges? Yes, girls are underrepresented at Cambridge at the moment, and all of us are really focused in mathematics in the undergraduate body and in the postgraduate body, and we're really doing our utmost to address that, to encourage it, to convince. We also have an issue of application. We don't have a very large number of female applicants. Indeed, we know that Oxford gets more. We're really trying to encourage more applicants to apply. And we really are trying to encourage, to convince them that this is a good place to be. And we really are addressing every aspect. We have absolutely world-class mathematicians who are female on our faculty. Absolutely outstanding. I mentioned Julia Gog. There's also Mihaela van der Schaar is our set up the Cambridge Centre for AI in Medicine, supported by AstraZeneca and GSK. We have Carola Schoenlieb, who leads our computational analysis group. She's just got an EPSLC fellowship. She's involved in a program grant. She's a world-class researcher. Maria Ubiali, who's in theoretical physics. She has got an ERC starting grant, from the European Research Council. Outstanding female academics. Because I'm head of Department of Applied Maths, I'm listing these ones off. In pure maths, there's also wonderful female academics too. We're really trying to encourage diversity in application. We're really trying to encourage to improve the diversity across not just gender, other underrepresented groups too, and every level. Now, is it true across the colleges? Admissions are decided by the colleges in the way I have described. I have another hat to put on with Churchill, but admissions are decided by colleges. There are some still women-only colleges, Newnham and Murray Edwards. They clearly the cohort is all female, but every college I know that I am aware of is really actively trying to encourage more women to apply, and absolutely consistently with fairness and focus on academic potential. No woman who gets into Cambridge should ever think she got in because she was only a woman. Only a woman. Most definitely not the case. Everybody is treated fairly. Everybody is treated equally. But we're really trying to encourage more applicants and also to do our utmost to support them when they're here. That's what's going on. It's just really important to all of us. Any key reasons you can think of for choosing Cambridge rather than Oxford? Wow, because you could take waves from me. That's one reason. So people who are resident in this island are so lucky to have such a strong university sector. The universities in the UK hit above their weight. They're global by every reasonable measure. The universities that are better than the higher ranked, more successful, etc., than the universities in obvious comparative countries like France or Germany or Italy. It's just, we're so fortunate to have so many good universities. Oxford and Cambridge are obviously always paired together. Oxford is a superb university to study mathematics. There we go. Why would I choose Cambridge rather than Oxford? We do supervisions every year. In their third year, they do example classes, not supervision. They call them tutorials. which is the right name, but that's a difference. We continue the small group teaching further on. We have a very wide range of courses. The structure of our courses allows you to do a very, very wide range of things in part 2. And it's a direct connection. Part 2, that's the end of our third year. First year is 1A, then second year is 1B, third year is part 2. Part 2, you have a very wide range of subjects, very flexible ways that you can take it. Also, it's a direct connection into our part 3, which is globally famous. There are typically, it's getting, we 250 to 300 people take this course every year. It's a master's course, has 80 different courses, lecture courses that you take 5 or 6. The Cambridge students, as I said, about the best 100, but last year was actually 120, continue on to do part 3. So the top 40 to 50% of our year cohort go to do part 3. And then about 150 or so, between 150 and 200 other places. We get over 1,000 applications from all over the world to come and take that course. So a direct connection with part 3 is a real selling point. And in the presence of supporters, I also want to say in Cambridge, the colleges give you accommodation every year. And that's a big deal. You don't go out into the private sector. You're always organized. You're always in the college. One less thing to worry about, and you've got that community built in. So that's a thing. Roughly what ratio of UK, non-UK math students do you have? I think it's about 75% UK, I think, at the undergraduate level. Much, much lower proportion of UK students in part 3 and at the PhD level. Are you able to say what the impact of COVID might be on applications, numbers per year, grades, and how this might be managed? So we had, as I kind of alluded to, hinted at in part 3, there was a slightly larger year group in last year than expected. This coming year, STEP on the other hand runs quite well, and that is the major discriminator that kind of controls our numbers, because as I say, only about 160 pass it, get the 1-1 or higher, and so then we're able on the margins to do it. We are laser focused on addressing these issues. I think one of the things that we are thinking about is about what the knock-on effect might be for the preparedness. We design our Michaelmas, our first term, the course before Christmas, the term before Christmas is called Michaelmas, and the Michaelmas first year courses are designed to sort of link very well with a certain level of knowledge from A levels and so on. And so we're very much going to be monitoring very carefully about whether the incoming group who've had their A level studies effectively disrupted from the very beginning, how they're affected. We expect the numbers in maths to be pretty much the same. We will be doing offers 1-1. We don't know. We'll mark the STEP as usual. We don't actually know. We didn't see last year a marked poorer performance. So I think it will be. So I think we will expect it'll be fine. But we are carefully paying attention to it. Find isn't the right word. I do not expect there will be a major difficulty like there are in some other subjects where the great attention is paid to the A levels play a key role. Is there any financial help for Spanish students? I do not know. I'm sorry. That is too specific for my knowledge. I don't know. You should look at the university web pages about the various sources of finances that are available. I can't answer the question. My son has autistic spectrum disorder. Should this be disclosed on his application, and how is this taken into account in the application process, if at all? That's a very good question. So I should have mentioned when I was listing, but I kind of don't really like the name, the Disabilities Resource Centre greatly supports people on the spectrum throughout their studies here. So there was a period I was lecturing one of these first year courses. Before the start of the course, you get a list of students who've self-identified to the Disability Resource Centre, you know, about please give them notes beforehand, please don't use these colours, please be very precise in your instructions. You know, we're trained and we know these sort of things that happen. I would recommend that you would disclose this on the application, because that then makes it easier for the people who are interviewed to take into account, who are doing the interviews, to take into account your son's special needs. So for example, you know, we all have training on this. So about being very precise in your instructions, avoiding noise, you know, having an opportunity to familiarize yourself with your surroundings, all these sort of things can then be helped to ensure that during the interview, your son is not stressed and not disadvantaged. And throughout the process, that is factored into the aspect of we're trying to identify those with the highest academic potential. In your presentation, it said that tuition fees are much more expensive for overseas. Oh, I'm sorry, before I finish, I should say, however, you know, I am recommending personally that it would be helpful with respect to your son's experience during the interview process, that is, that you mentioned his special needs, but there is not an obligation to do so. And as I say, he will always continue to be treated fairly. But I personally would recommend it. From my experience as admissions tutor, it was good that that piece of information was provided to us, and it would be no disadvantage to it. So now back to the fees. It said that tuition fees are much more expensive for overseas students. How do you determine if a student is considered as overseas student? There is a process. My son is an EU citizen with settled status and has been living and been in education in the UK since age 3. I do not wish, and I'm not qualified to comment on particular situations. What I recommend in this, I believe that the decision on the funding is a detailed decision associated with residency as well as citizenship. And clearly, because of Brexit, the rules have been changing recently. The situation I would recommend you to do is to contact the college to which you are intending to apply with the full details, because they will then be able to give you, I would have thought, a preliminary decision about whether you would be considered to be home fee status or not. There's a kind of checklist of different situations, and all I can say is I know it is very complicated. You know, particularly, you know, the treatment of people from the EEA, the Swiss and the Irish are treated differently. It's all there are a set of rules, and I wouldn't want to make a statement one way or the other. Directly contact the admissions office of the college that you were thinking of, and that's the sort of thing that they would be able to advise you on. If you don't get an offer but score high marks on STEP, is it possible to get into Cambridge via the adjustment process? I'm sorry, I do not know. I cannot say with confidence the answer to that question. I don't know. I'm sorry, I don't know the answer to that question. I know I do not know whether mathematics is participating in the adjustment process in this coming year. I do not know the answer to that question. I'm sorry. What percentage of people who get an initial offer end up not getting accepted in the end because they don't get a 1-1 and don't get fished by another college? So that's a good question. About 500 people get offers and 250 get in. It's about 1 in 2, roughly speaking. It by no means do we is that sort of done? You know, there's no sort of idea that there's 500 offers, because the decisions are made independently by each of the colleges, but it's roughly that. Thanks. Thank you. Somebody said thank you. You're very welcome. How much emphasis do you place on extracurricular activities, e.g. sports, music, etc. at interview? I can say with confidence that extracurricular activities play no role in the decision making for mathematicians at Cambridge. Define when we mean extracurricular, sports and music. Now, extracurricular involvement in maths Olympiads, various mathematics competitions, if you've really excelled at them, they can certainly play a role. If you've got a goal, I think straightforward, it would be highly unlikely that we would reject somebody who got a gold medal at a IMO. But in terms of sports and music, no. Right? The anecdote I have for that is there was one student who thrived at Churchill, and in the section for extracurricular, bit about maths, there was only a single sentence: "In my spare time, I enjoy doing maths problems." was what this individual had written, and they were fine, and that was fine. Now, that is not recommending you to write something so sparse, because other universities do pay attention to that. I have been reliably informed. But at Cambridge, we're interested in your mathematical potential, and that's it. Of course, for some people, good mathematicians are good at chess, and some good mathematicians are good at chess. I was beaten by when I was 19, and my younger brother was 7. He beat me at chess. I'm no good at chess, but and I'm okay at maths. But it's not. It doesn't play into it. We're interested in how good you are at maths. You mentioned there is a slew of bursaries and scholarships in place for UK, and I meant to only say UK at the moment, and EU students. Would there be any financial support? It varies. There is some. You go to the funding, the primary website lists off various funding sources, and also you should inquire of the college that you're interested in applying to, because there is also sometimes college-specific funding. And another thank you. I really appreciate it. Thank you. So I think I've got to the end of the questions, and okay. So I think maybe Ursula should come back, and we'll say goodbye. Are you still there, Ursula?
Yes, I'm still here.
Yes.
Okay. Yes, thank you very much. Some of the answers to some of the questions posted will also be available online. We'll gather frequently asked questions. So some of those answers you'll be able to see later. Thank you very much, Colm, and thank you all for attending and to ask questions that will be helpful. This will also be recorded and posted on our YouTube channel. Thank you. Bye.
Okay, thank you very much to all, and the very best of luck to everyone. Okay, thank you.